Hello and welcome back to my YouTube channel. My name is Professor Govala, and today I'm going to be doing a complex RL circuit step response example. And this example builds off a previous video that I did called Step Response of an RL Circuit Clearly Explained, which I will post a link to that video in the top right hand side corner of this video. So feel free to check that out. And essentially in this problem, we're tasked with solving for and graphing for the current and voltage at t is greater than 0 through this 1/3 Henry inductor. And essentially, if you can imagine, for a time t less than 0, my switch is connected in this configuration. And then at time t is equals to 0, it opens up and it's in this configuration. Next, in the process of solving for these parameters, we also want to solve for the current and voltage through the inductor at time is equals to 1/15 seconds, time is equals to 1/10 seconds, and time is equals to 5 tau, where again this tau is this time constant, which again we discussed the importance of this variable in our previous video. If you want to pause the video and try this complex problem by yourself before coming to the video and seeing if you received the right answer, feel free to do so. So to begin solving for this problem, we have to take the first case, which is case 1, where t is less than or equals to 0. And as you can notice, my switch here is closed. So that means that my current is going to flow through this short wire and not through this 3 ohm resistor. So we can get rid of that. And after a long period of time, since it's been in this closed position for a long period of time, and since my inductor here has been charging for a long period of time, we can essentially get rid of it and replace it with a short circuit. We can then write that I of t, where t is less than or equals to 0, is equated to basically my current through my 2 ohm resistor, right? Because it's going to flow like this. This here is I of t. And using Ohm's law, we can say then that this is 10 volts over 2 ohms, which is essentially 5 amps. And from a past video that I did called What is an Inductor Clearly Explained, again posted on the top right hand side corner of this video, we know that current through an inductor cannot change instantaneously. So that means that the current I at 0 minus, or right before my switch opens, to the current at I at 0 plus, or right when my switch opens, is equals to the current at 0, which is essentially just 5 amps. And again, this is at t less than or equals to 0, which is also called my initial condition. And this is my solution for case number 1. So the next case we need to consider is case number 2, where time is greater than 0. And essentially what happens is, since my circuit opens up, this now becomes an open circuit. And since current can't flow through it, we can get rid of this section right here. And we know that from our past videos, we can use what we labeled as the FIFE equation, which says that I of t is equated to I final plus I initial minus I final times e to the minus t over tau, where essentially tau is equals to L over R Thevenin, where L is equals to 1/3. And we need to find R Thevenin. And we know that R Thevenin is essentially the total resistance when we look in through our terminals, call this A and B, and when this Vs is equated to 0. So then we can say then that R Thevenin is equals to just 2 plus 3, since they're in series, which is equals to 5 ohms. So then tau is going to be this 1/3/5 ohms, which is equals to 1/15 seconds. So now we know everything we need for the exponential. We know our initial condition. So we just need to find our final values to input in here. So as time goes on to infinity, we can say that I of infinity is going to be the current through this circuit. And using Ohm's law, we could equate this to 10 volts over 2 plus 3 ohms, which is equated to 2 amps. And another way to look at it is after a long period, the current through the circuit saturates to 2 amps because the inductor acts like a short circuit to DC at steady state. Thus, what do we have? We have IT is equated to 2 from here plus 5, which is my initial condition, minus 2 e to the minus 15 t, which is equated to 2 plus 3 e to the minus 15 t amps. Again, this is at t is greater than 0. And therefore, we can write our total I of t as this: 5 for t is less than or equals to 0, and this 2 plus 3 e to the minus 15 t at t is greater than 0. And again, this is in amps, and this is also in amps. So in the process, the problem wants us to find I of t at t is equals to 1 over 15, at t is equals to 1 over 10, and at t is equals to 5 tau. So this is I of 1 over 15, which is equals to 2 plus 3 e to the minus 15 over 15, which is equated to 3.103 amps. This here is I to the 110, which is going to be 2 plus 3 e to the minus 15 over 10, which is going to be this 2.66 amps. And this here is I to the 1 over 5 tau. 5 tau is equals to 5 times 1 over 15, which is 1 over 3. So let me go ahead and change this to 1 over 3. So this becomes 2 plus 3 e to the minus 15 over 3, which is equated to 2.020. And as you can see, this is saturating and going towards 2 amps, which is my final current 2 amps here. So now let's go ahead and graph this and see what we get. So we can say then that on my y-axis, we have this I of t, which again is in amps, so I'm not going to keep writing amps, and t, which is in seconds. So the values we care about here is going to be this 5 amps. Again, because at t is equals to 0, we get 5 amps. And if you plug it in here as well, e to the minus 0 is 1, and 2 plus 3 is 5. So I hope that makes sense why 5 amps is important. The next tick mark we need is going to be this 3.103 amps. The next one we need here is going to be 2.66. Next one is going to be 2.02. And the last one is going to be 2. And again, this isn't drawn a scale, but we know that my current is going to saturate at 2 amps. For my x-axis, we want 1 over 15, 1 over 10, and 1 over 3. Again, this is just 5 tau. So then let's go ahead and plug in our values. So we're here. We have a point here. We have a point here. A point here. And what we're going to notice is that from t is less than 0, less than or equal to 0, our graph is going to just be at 5 amps. And then it's going to saturate. It's going to go down exponentially towards 2 amps and saturate at 2 amps. Generally, we consider this to be what's called the transient state. And that is because after this state, the inductor essentially becomes a closed circuit, and essentially my current is going to saturate at a value of 2 amps. And after the transient state, we have what's called the steady state. And essentially, this is why the problem wanted us to consider 5 tau. Okay, if you have any questions or concerns, please leave them down in the comment section below, and I'll be sure to get back to you. And so for the last part of the problem, we want to get the voltage V of t through the inductor. And we know from a video that I made called What is an Inductor, we know that the voltage through the inductor is going to be the inductance times the change in current over time. So for our situation, our inductance is 1/3 henries, and we have that our change in current is going to be d5 amps over dt for t less than or equals to 0, and d over dt 2 plus 3e to the minus 15t for t greater than 0. So then we can rewrite v of t as this. The first part here is essentially going to be 0 for t less than or equals to 0. And this makes sense, right? Because essentially you need a resistance to have a voltage drop. And since the inductor is a short, i.e. little to no resistance, there cannot be any voltage drop. And now for the second part, this part of my function, we're left with 1/3. The derivative of this inner part is going to be 0 minus 15 times 3 e to the minus 15t volts for t greater than 0. We can clean this up and say that this is minus 15 e to the minus 15t volts, essentially because this 3 cancels out with this 3. Okay, let's go ahead and consider at t is equals to 1/15. We get v of 1/15. It's going to be minus 15e to the minus 15/15, which is this minus 5.518 volts. At t is equals to 1/10. We get v of 1/10 is equated to minus 15e to the minus 15/10, which is equated to minus 3.34 volts. And at t is equals to 5 tau, which is equals to 1/3, we get v of 1/3 is equated to minus 15e to the minus 15/3, which is equals to minus 0.101 volt. And as you can see here as well, it's saturating basically to 0 volts, essentially because the inductor again is becoming a short circuit, resulting to 0 to no resistance value, which means that my voltage will essentially be 0. So the last thing we need to do now is go ahead and graph this. And essentially what we're going to have is something like this, where the y-axis is going to be v of t. Again, this is going to be in volts, and the x-axis is going to be in seconds, time. So now what are some points that we care about? We care about 0 because at t less than or equals to 0, my voltage is 0. But then also an instantaneous rise at t is greater than 0. For example, if we plugged in 0 into here, we would get negative 15. So then this would be negative 15. Another point we care about is this minus 5.5. So again, this is not drawn to scale, but minus 5.518. Another one we care about is going to be this minus 3.34, and then this minus 0.101. So on the x-axis, the points we care about again is this 1/15, 1/10, and 5 tau, which is equals to 1/3. So let's go ahead and plot this. We get that at t less than or equals to 0, my voltage is basically 0 because, again, the inductor is a short circuit. And then when we open our switch, it shoots up instantaneously to this negative 15 volts. And then at 1/15, we have negative 5.5. This is here, and this is here. So it's essentially going to saturate right back down to 0. Again, because as my switch opens up, my inductor becomes a short circuit, again, making voltage to essentially not drop through it or become zero. Now, again, in this situation, this is going to be my transient state. And essentially here is going to be my steady state. Now, in the comment section below, I want you to let me know why this value instantaneously changes, but in the negative direction. All right. And I'll pin the first comment that is correct, and I'll also respond to that first comment. Okay. If you have any questions or concerns, please leave them down in the comment section below, and I'll be sure to get back to you. If you liked the video, please give it a thumbs up and please share it to your friends and colleagues. And if you like what the YouTube channel is providing, please consider subscribing. It really helps the algorithm. Thank you.